Sometimes you care about fast control, sometimes slow control. You can't compare apples and oranges because the KPIs, the controller performance, the objectives of those could be different, right? And you may need to actually treat that as a state, separate the analysis and treat it as a state condition. And you probably don't want to do it if you're doing like gain scheduling where there's an infinite number of gains between A and B. You may try to put them into buckets and say, look, if I'm between these two parameters, I'm in an aggressive, and these two parameters, I'm a conservative. But a lot of it just also depends on, Tim had said earlier, keep things simple. It depends on how complicated, how important, how much economic value there is to solving the problem, right? I love data. Give me more and more data. I'm all for it. If you need to solve the problem, generally you need a very small amount of data to get 85% of the answer, right? But that last 15% of the answer, that's the expensive part. And you may get a decent value from it, but it's still a lot of work to get the last bit. So yes, you could treat it as a state, but you have to ask yourself, is it actually significant enough of value enough to do that, right? It's the same reason we could put adaptive control on every single PID loop that we have in the plant, but we probably don't need to do that because the value of the return isn't necessarily there for it. So you kind of have to do that little bit of that calculus to determine is the value there before you start applying a bunch of additional states and conditions and so forth to your system. So excellent.